All right, today we're going to be learning about parallelograms. Parallelogram is a quadrilateral, so four-sided shape, where both pairs of opposite sides are parallel. So if we're looking at this, we have that these two guys are parallel to each other, and these two sides are parallel to each other by definition. So that's just given. If it's a parallelogram, you know the opposite sides are parallel. Now there's a whole bunch of properties that come into play with parallelograms that we're going to explore and use to our advantage. So the first one is that in addition to the opposite sides being parallel, we also have that opposite sides are congruent to each other. Okay, so opposite sides are congruent to each other. So in addition to being parallel, these two sides are congruent to each other, and these two sides are congruent to each other. And we also have the opposite of that. If we know that a shape has opposite sides being congruent, then we automatically know that it's a parallelogram. So it works both ways. If it's a parallelogram, then we know opposite sides are congruent. If opposite sides are congruent, then we know it's a parallelogram. Over here for the next one, we also have that opposite angles are congruent. Okay, so opposite angles are congruent. So that's saying that, oops, that's not a highlighter, that this angle and this angle are congruent, and this angle and this angle are congruent. And same thing, it works both ways. If you know it's a parallelogram, then you know opposite angles are congruent. If you know opposite angles are congruent, then you know it's a parallelogram. So let's just use those to our advantage right now. If I'm looking at this first one here, I can see that it's a parallelogram because I have the markings here telling me that opposite sides are going to be parallel to each other. So that means I know, in addition to being parallel, that opposite angles are congruent and opposite sides are congruent. So I could start off by saying, hey, x plus 4 has to equal 12. And then I can also say the opposite angles of y and 65 have to equal each other. All right, so x is going to have to equal 8, and y is going to have to be 65 degrees, for being nice and precise here. So that's the first one. All right. On the next page, this time around, they give us it in words. So my suggestion is always that you draw a pretty picture. So when we have a quadrilateral WXYZ, I'm going to draw a four-sided shape. I'm just going to start in a corner and just go around either clockwise or counterclockwise. And then I'll fill in what I know about it. So here's 42 degrees. They tell me x is 138. Y is going to be 42. They want us to first find angle Z and then decide if it's a parallelogram or not. So what we're going to use is something from one of our earlier lessons, which is we know that all quadrilaterals, interior angles add up to 360. So what I'm going to do is say, hey, 42 plus 138 plus 42 plus angle Z is going to have to equal 360. And then I'll just use my fancy dancy calculator to figure out what's going on with that. So let's see, if I do 42 plus 42 plus 138, that's going to be 222. So I have z plus 222 equals 360. If I subtract that from 360, I get that z is equal to 138 degrees. Okay, so if z is 138 degrees, when I'm looking at this, I have opposite angles are congruent to each other. So my answer to this question is yes, WXYZ is a parallelogram because opposite sides are congruent. Opposite angles, sorry, are congruent. Whew, words. All right, your turn. I would suggest you pause the video and try it yourself, and then unpause, and I will be here waiting for you. Did you pause the video? You better. Let's see, we got a parallelogram. We know opposite angles are congruent, and we know opposite sides are congruent. So we can set up two little equations here. 2x equals 50, so x is going to equal 25. And then I have y plus 3 will equal 18. And so y will equal 15. Not too terrible, right? All righty. We're having so much fun, aren't we? Aren't we? Okay, I am. So, diagonal lines. We connect opposite corners here. We get diagonals. So you can see connecting AC is one and connecting B and D is one. And in a parallelogram, the diagonals bisect each other. So what that means is that this part and this part are equal to each other. I'm going to use slightly different colors, I think. I'm going to do this. So like this part right here is going to be congruent with this part right here. And then we also have that this part right here is going to be congruent with this part right here. They're not necessarily congruent to each other, but we know that each half, okay, so like this part right here and this part right here are going to be congruent, and this part right here and this part right here are going to be congruent. And vice versa, same thing as before, right? If we know that the diagonals of a quadrilateral bisect each other, then it's automatically a parallelogram. So we can work forwards and backwards. All right, so I'm gonna kind of clean this all up because it got a little messy in there, but basically you can see the two swipe line here, and then we have the one swipe line here and here. Those are going to be congruent. So for this one, for what value of x is this a parallelogram? So we can see that they already have marked these guys off. If this is a parallelogram, then this line right here is going to have to be congruent to this side right here because they would have to bisect each other. So I would be able to say that 5x minus 8 has to equal 3x. And then I might subtract the 3x and add the 8 to the other side. So I'll get 2x equals 8 and x equals 4. So if x equals 4, the diagonals will bisect each other. And that means that it is a parallelogram based on this little theorem right here. All right, so we have coordinate geometry that exists in this. So basically coordinate geometry, if you forget, is when we are using geometric properties with algebra coordinate planes. So it says the diagonals of parallelogram LMNO. So I think I might have forgotten to go over that this is the symbol. We kind of draw a little slanty rectangle, and that's the symbol for a parallelogram. All right, and so what we know is that they bisect. So that means that if this line right here, right, it gets bisected by this point if this is a parallelogram, which means that that's a really fancy way of saying it's the midpoint. So all I need to do is just figure out what the midpoint is between any one of them, either O and M or L and N. So I'm going to use O and M. So O is going to be at 0, 0, and M, it looks like, is at 7, 4. And I'm just going to use the midpoint formula, which, remember, is you add the two x values, divide by 2, and you add the two y values and divide by 2. So that's going to give me 7 over 2, or 3.5 if you want to write it as a decimal. And this is going to give me 4 over 2, which is going to just be 2. So I actually know that point P must be at 7 halves, or 3.5, 2, and it kind of makes sense if I look at the graph. This looks like that would line up. One way we could double check ourselves is to use the other point. So if I used L, which is going to be at 1, 4, and N, which is at 6, 0, if I did the midpoint formula here, 1 plus 6 over 2 and 4 plus 0 over 2, I am also going to get 7 over 2 and 2. So no matter what, didn't matter which diagonal I used, since we know that they bisect each other, that means that they are going to intersect at a midpoint. So we can use that to our advantage. All right, your turn. For what value of x is a quadrilateral MNPQ going to be a parallelogram, and decide how you know. So you should pause the video and you should try this yourself. Okay, I'm sure you did that, right? So explain my reasoning here. What I'm going to use is the fact that I know that diagonals bisect each other in a parallelogram. So that means that if I have this marking here and here, well, then I need to have these two be congruent as well. So I know that 2x must equal 10 minus 3x. I'm going to add the 3x to the other side and then divide by 5. And I get that the value of x equals 2 is what's going to ensure that the diagonals bisect, which means that it will be a parallelogram. Woo, so much fun, right? So just wanted to remind you about a property that we already know, which is in parallel lines, same side interior angles are going to add to 180, right? So if I have same side interior right here, that we know that they are going to add to 180. Well, this property is going to hold true inside of a parallelogram because it has parallel sides. So that means that if we have same side, so on the same side here, that these guys are going to add to 180 right here. But it also can go this way. So I can go x and y this way, and that will also add to 180, or this way, or this way. So basically, anytime you have a consecutive angle, an angle next to itself, inside of a parallelogram, they have to add to 180. And if we scroll way back up to some of the questions we've already done that had angles, and go way up here, 42 and 138 add up to 180. 138 and 42 add to 180. 42 and 38 add to 180. 138 and 42 add to 180. So we've already seen this property, we just didn't really know it. So if we want to use this, then we can say, hey, these two angles are next to each other inside of a parallelogram, and so we know that they have to add to 180. So I can just make a little equation and say, hey, you need to add to 180. That's going to give me 3x plus 30 equals 180, and 3x equals 150, and so x will equal 50. So the value of x that makes this thingy a parallelogram is going to be 50. All right, it is your turn. You should try to figure out the measure of angle y inside of this one. So you should pause the video and give it a go. All right, I know you paused the video because you would totally listen to everything I say. Well, we know that angles that are next to each other inside of a parallelogram have to add to 180 degrees. So y plus 119 has to equal 180. That's going to give me that the measure of angle y equals 61 degrees. Done. All right, we have a couple other properties. This one's a little weird. We don't use it super often, I have to be honest with you, but it says that if one pair, so a single pair of opposite sides of a quadrilateral are both congruent and parallel, okay, so they need to be both congruent and parallel, which we can see right here with the markings, then we automatically know that this thing is a parallelogram, okay? So basically, it's just the last of the main theorems, which says that if you have opposite sides are both congruent and parallel, then you know it's a parallelogram. Here are the 5 main ways that we can show that something is a parallelogram. This is basically a summary of all of the big theorems that we've learned today. So we could show that both pairs of opposite sides are parallel. We could show that both pairs of opposite sides are congruent. We could show that both sets of opposite angles are congruent. The one we just talked about, opposite side is congruent and parallel, or we could show that the diagonals bisect each other. Any of these 5 ways work for us to be able to show or prove that a 4-sided shape is actually, very specifically, a parallelogram. And that's exactly what we're going to do on our last question of the day, which is show that this quadrilateral ABCD is actually a parallelogram. So what we're going to use is pick one of these ones up here, one of these 5 to show. And in my opinion, the easiest one to show is to show that opposite sides are parallel, because all I have to do is just find the slopes of all 4 lines and then just show that 2 of them are the same and the other 2 are the same. And that will make sure that I have opposite sides being parallel. So that's our plan. We're going to show that opposite sides are parallel using slope, okay? So let us start with the slope of AB. Okay, so when I'm using this guy right here, that looks like I'm going up to and over 5. All right, so now I want to do the opposite one right with it. So I'm going to do the slope of the opposite side, which is going to be CD. And it looks like I'm going 1, 2, 3, 4, 5, and up 2. So its slope is also 2/5. So I know that AB is parallel to CD because they have the same slope. Now I'm going to look at the other ones. So let's do, I shouldn't use the same color green. Let's switch to red. Let's do slope of AD. So that's going to be, we're going, looks like down 3 and over 3. So its slope is going to end up being -1, because if I go down 3 and over 3, that reduces to -1. Let's look at what our slope of BC would be. And it looks like it is going to be the exact same thing. So that means I know that AD is parallel to BC. And because I have opposite sides are parallel, then I know that ABCD is a parallelogram. So I can say ABCD is a parallelogram. That's a fun word to spell and say, because opposite sides are parallel. Done. Not too crazy, right? All right, your homework is to do the practice. So you're going to use these properties. Remember, they're kind of summarized right here. These are the 5 big properties that we have. So you'll use those to figure out questions 1 and 2, see if you can figure out 3. It's a little tricky sometimes. And then in number 4, you're just going to pick one of the two to solve, and you're going to show that it is a parallelogram. You can use any way you want. In question 5, it's a little bit different. What it does is it gives you 3 of the 4 points, and what you need to do is try to figure out what the 4th point is. And in that one, I would use unsimplified slopes to try to figure out. So basically what I mean by that is, let's say we were looking at this one, and you didn't know this point over here what it was. Like, it just wasn't given to you at all. So I'm like erasing it so it's not there. What we could use is say, hey, if I went down 3 and over 3, that's an unsimplified slope. Then I could do the same thing, down 3, over 3, and then I could figure out where this point needs to be in order for it to be that exact same size and shape. So that's what I would do personally, is just look for patterns to see where the shape, the point should be on that question 5 down there. And I believe that's it. So hope you enjoyed the video. Don't forget to like and subscribe, and I'll see you in the next one.